Hi, this is Mrs. Slater. Today we're going to start out with a joke and then I'll answer it at the end. What bear has no teeth? All right, notes for 11.2 begin with the remainder and factor theorems. To start off, we'll talk about the remainder theorem. This one is saying that the remainder is the function value, which, as you can see, we start discussing in the very first example. Okay? And the factor theorem tells us that if remainder is 0, then the original factor, is a factor. And it depends on what they give you. They could give you a x minus 2. That's what I mean by the original. So that could be a factor. So as long as you get a remainder of 0, that practices, or that's the same line of what we did yesterday. Okay, so the function value. Again, just a little practice on synthetic division. So this 2 is going to go inside of the box for the format. And then you have your coefficients. Don't forget the case of the missing term right there. And then list all the other ones. You got -3, 1, and -2. Go ahead and push pause and practice that. And you get 3, 6, 10, 20, 20, and then 40. And you continue on to get 37. And then after that, 37 times 2 is 74. And that adds to 75. And you can see we're going to have a remainder. So this number right here is called the function value of p of x. So p of x is the original polynomial. Okay, so what that means, if your graph, it looks something like this, that means that 148, or over 2, maybe this isn't the best picture, but over 2, 1, 2, and up 148, the graph is actually going to go through that point, that ordered pair. So that's why it's called a function value. That is the y value. Okay, let's go ahead and practice on another one. And it looks like I have to go back and straight down. Okay, again, push pause. Go ahead and do the synthetic division. And the exact same we're going to use for the polynomial. So we have 3, 4, 0, -3, 1, and -2. And then when you put in a -3, you're going to drop the 3 and continue on. So go ahead and push pause and finish it, and then we'll check our answers. So hopefully you got -437 as the remainder. And if that is the remainder theorem says that that is called the function value, or the y value of the graph. So again, an ordered pair would be -3, comma, -437. That's where it would hit, one of the points that it hit on the graph. Okay, the next one, I have a different polynomial for you to do. The last number was a pretty big number, but this one is even more crazy. So go ahead and push pause and see if you can find the function value. All right, so here we go with the coefficients. We have the case of the missing term once again. And then if you drop that first one, you're going to multiply and get -10, then -20, 200, 220, -2200. I'm going to start writing small because my numbers get a little crazy. And then 22,000, 21,995, -219,950 for a final function value of 220,050. All right, so function value, FV for short. There we go. And then again, push pause to go ahead and do number 5. You've got 1, -10, 20, 0, -5, just written like above. And the function value we can find by solving synthetic division and get the remainder. So drop the first one. You've got 5, -5, -25, -5, -25, -25, -125, -130, -650, and then -750. So there, once again, is our function value. Both of those would be points on that polynomial. All right, let's go on to the next one. On number 5, it's saying find all the roots knowing of that polynomial, knowing that negative 2 is one of the roots. Okay, so you're going to see this in your classwork as well, so I'm going to write this down off to the side. We're going to show that, pardon me there, so we're going to show that the negative 2 is a root. And based off of lesson 11.1, we know how to do this. And again, we've just practiced synthetic division, so we're going to do that once more. Okay, I'm going to take all of the coefficients and do synthetic division. And it's a good idea to push pause and see if you can do this on your own. Okay, hopefully you get a remainder of 0. That's what we wanted to happen. It told us that it was one of the roots. This emphasized the fact that it is a root. Okay, so yes. So the next part of what you're going to be seeing in these type of problems is it's going to say find, let me get a different color. It's going to say find another factor by factoring the answer. Okay, so we know that the answer is not really 1, negative 8, 15. Okay, it's actually with variables in it. So it'd be x squared minus 8x plus 15. Okay, so let's factor this. X and x. Factors of 5 or 15 that will give us negative 8 or negative 3 and negative 5. Okay, so you have just accomplished your goal. We found another factor. Not only did we find another factor, but we found a second one as well. So that leads us to the next question. Write the complete factorization. So all the factors that apply here for this function, remember the original function was p of x. We have x minus 3 as one of them, right up here. We have x minus 5 as the next one, right here. And then the other one is kind of hiding up here. So remember how this one worked? That means if that is a root, if we solve for 0, that means you get another factor. So that is also going to be in our complete factorization. So all three of those, if you multiply those together, you would get the original polynomial. This guy right here equals those three factors. All right, and then the last thing I want you to do is solve the equation. Solve the equation and set p of x equal to 0. So what that's going to look like is 0 is going to go there, and then here are all your factors. And then by using zero product property, you can set all of those equal to 0. So you get 3, 5, and negative 2. All right, and the last one is very similar to this. Oh, I don't know. Okay, there it is. Find all the roots of p of x, new polynomial function. And I already know that a couple of those are wrong, so right above it, I'm going to have you write a new polynomial function, which is, or right below it, either way, x cubed minus 4x squared plus x plus 6. You're going to like it better, and I like it better. Okay, so we already know that 2 is one of the roots. So we're going to show that 2 is a root by synthetic division. So we put it in a 2. Go ahead and push pause and see if you can do it on your own. And you get 1, negative 4, 1, and 6. Drop that first one, and then you got 2, negative 4, negative 3, negative 6, and 0. Okay? For the answer, we don't leave it in that form. We should actually put the x's back in. So that would be x squared minus 2x minus 3. And then we want to go ahead and factor this to find some more factors. So it will factor into x minus 3 and x plus 1. All right, so you got your factors. Now we can write the complete factorization. And p of x would now equal x minus 3, what we just found above, x plus 1, found that one. And the other one, like I said before, is hidden. You've got to look up above. See, 2 is a root. So if 2 is a root, that's x equals 2. And if you set it equal to 0, it would be x minus 2. So right there is your factor. So we're going to put a factor in there for complete factorization. Okay, and then After that, let's solve the equation for p of x equaling 0. So this is where the zero product property is going to help us out. And we set all of those equal to 0 to get 3, -1, and 2 for all of our roots. All right, this concludes 11.2. And the answer to the riddle was, well, let me say the question again. What bear has no teeth? The answer, a gummy bear. And the quote for the day is, don't cry because it's over, smile because it happened. I'm sure you're thinking about that with this lesson. So, whoop, whoop.